9.2 Taylor series. So in this little video, we're going to talk about Taylor series that are set at x equals 0, which is what we've been working on. When you have a Taylor series centered at x equals 0, it's a very special Taylor series called a Maclauron series. Because Taylor series can be oriented at any x value 1, 2, 3, and 4, and we'll see how to do that later. But when you have a Taylor series at x equals 0, it's a special Taylor series called a Maclauron series. So if they ask you to find the Maclauron series, they're really just asking for a Taylor series at x equals 0. So let f be the function with derivatives of all orders, which means you can do the derivative as many times as you want, throughout some open interval containing 0. Then the Taylor series generated by f at x equals 0 is going to be f of 0 plus f prime of 0 times x plus the second derivative at 0 divided by 2 factorial x squared plus the third derivative over 3 factorial times x cubed plus ... and you're going to follow that pattern until you get to the nth derivative, plugging in 0, dividing by n factorial x to the n. Again, that's like the 500th million derivative over 500 million factorial x to the 500 million, which will equal sigma n equals 0 to infinity f k of 0 k factorial x to the k. And k is just a replace for n. That's really all it is. So if you want to be able to find any term, it's this equation right here. So this is called a Maclauron series. If you see something written like this, it's a Maclauron series. And if you want to find the partial sum, it's going to be from k equals 0 to n. Instead of going to infinity, we're going to a finite n value. And this represents the Taylor polynomial of order n at x equals 0.